going to talk about, we're going to talk about the next type of transformation. Right? The next type of transformation you might be the most familiar with, because it seems like anytime I see students using some type of electronic device, they're taking advantage of this transformation. This transformation is called a size transformation. Now, when I say size transformation, it seems kind of self-explanatory. We are changing the shape's size, right? So here I have my Prezi, right? I have two buttons here. I have zoom in and zoom out, right? When I hit the zoom in button, what happens? The hexagon that we're using got bigger, right? Got bigger in every way, right? Got bigger in the x direction, got bigger in the y direction, didn't it? Right? I didn't stretch it horizontally or stretch it vertically. It got bigger in both directions. Does that make sense? Okay. Same thing was when I zoom out, what happens? It gets smaller. This is a wonderful example of a size transformation. So the translation we're talking about next, the transformation we're talking about next is what's called a size transformation. Right? When we have a size transformation, either the size of the shape will increase or it will decrease. And it all depends on our scale factor. Right? So a size transformation is increasing or decreasing the size of a figure. I said figure object of a figure by a scale factor S. Okay, so S is just a number, it's just a variable. Right? Thank you. Now, has anyone ever used a microscope before? Yeah. Yeah, like a microscope, you have like 20 times zoom, 50 times zoom, right? 100 times, whatever it is. Okay. That is the scale factor that they're increasing your view of the figure by. All right. Now on Prezi, the scale factor I think is like 1.5. So I click zoom in, it gets 50% bigger on all sides. Okay. I zoom out, it gets about 25% bigger or smaller on all sides. All right, scale factor is 1.5. All right. I think. I'm not for sure. I didn't measure or do anything like that. But it's not. It doesn't double. It doesn't triple. It doesn't go in half. All right. But the scale factor, guys, is how much the figure increases in size by. All right. Does that make sense, Maddie? Okay. Now we are going to work on size transformations where we are only stretching both x and y the same. Okay. So the rule we're going to use looks like this. X comma y becomes Sx comma Sy. They're probably saying S. Sure aren't fives? No, they're S's, because S stands for any number, right? And what operation is being done here?
Multiplication.
Multiplication. So we're taking the scale factor and you just simply multiply by the x and multiply by the y. And what this produces, it produces an increase or decrease in the size of the object that is centered on the origin. So all of our size transformations that we're working on are going to be centered on 0, 0. So in the book or on a test, if they say conduct a size transformation centered at the origin of magnitude 3, right? That means your scale factor is 3. We're multiplying everything by 3, and we're using this rule. All right, any questions? Now we said increasing and decreasing, right? So what S value will make our figure bigger? What type of S values make our figure bigger? Bigger. What type of S value will make our figure bigger? A big number, right? Bigger than what?
0.
Bigger than 0? Bigger than 1. Okay. If S is bigger than 1, all right, that is what's called an enlargement. That is our zooming in. Okay. The image, the second thing, right, will be bigger than the pre-image. The second one will be bigger than the original. Okay. So then if I want to make it smaller, what has to happen?
Smaller.
That has to be less than 1. And that's what's called a contraction. And in a contraction, the pre-image would become the image. That's so relevant. Now, can S be negative? No. S can't be negative. If S is 0, what happens to the shape? It disappears. Because everything times 0 is 0. Okay. All right. Any questions about what we have written here for size transformations? Any questions? All right. So in that video we saw all of the transformations, including size transformation. Which one was size transformation again? The cheetah in the tree. As it was breathing, it was getting bigger and smaller, right? Right? Just like as I zoom in on my Prezi. Oh, I'm zooming out right now. Okay. Oh, got all centered. Okay. As I zoom in on my Prezi, my pink hexagon here is getting bigger, right? In a size transformation, are the pre-image and image congruent? Are they exactly the same?
Yes.
No. When I zoomed in on this pink hexagon, what happened to these side lengths? They all got bigger, right? When I zoom out, what happens to these side lengths? They get smaller. So the figure is not identical. The pre-image and image are not exactly the same. Right? So a size transformation is not an isometry. It is not a congruence transformation. Right? All right, so let's practice this. So this one says, perform a size transformation, or size dilation of magnitude 2 on ABC. So let's do that first.
So it's telling us to multiply it by 2.
So it's saying multiply everything by 2. So since it says magnitude 2, that means this right here, this is our S value. So our rule is going to be
S negative 2.
2x,
2y.
2y.
We don't gotta put the negatives in there?
Nope, there's no negatives. Where do you see negatives on? Oh, like on A, like right here?
Yeah.
Oh, we just plug that in for x. Okay? So like A prime, I take negative 2 and multiply by, which gives me negative 4.
Yeah.
We take 3 and multiply by 2, which gives me 6. B prime, we take 2 and multiply by 2, which gives me 4. 3 times 2, which gives me 6. C prime, 0 times 2 is 0. Negative 2 times 2 is negative 4. So now I found the coordinates of my image under a size dilation of magnitude 2. So now to see what it looks like, I graph it. So negative 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. A prime. 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 0, negative 2. Or sorry, 0, negative 4. 0. So there's my figure. Does it look like it's going to be bigger?
Yeah.
There we go. Is it bigger? A lot bigger, isn't it? Does that make sense? Does that make sense, guys? Yeah. Is this easy enough? Yeah. Thank you. All right. Now the reason why we say this is a size dilation centered at the origin is if I were to draw a line connecting B and B prime, or A and A prime, or C and C prime, what's it going to go through? If I draw a line connecting B and B prime, it'll go through the, or A and A prime, it'll go through the,
Origin, line of reflection.
no, I'll go through the origin. Okay? So that's why it's called center of the origin. Right? It's kind of that whole perspective thing you learned in art class. Right? I did like one of these things. Right? Now it kind of looks like I'm heading into like a triangular tube or something. Right? So that's why they're called center of the origin, because the line containing the image and the pre-image would pass to the origin. Alright. Those little dots just kind of. Alright. Any questions about how we found A prime, B prime, C prime? Any questions? Does it make sense? Does it make sense?
Yeah.
But is this really 2 times bigger?
No.
It looks bigger, but we know for sure it's 2 times bigger because it says my magnitude was 2.
Yeah.
Are we sure it's 2 times bigger?
Yeah.
Yeah.
You're sure?
Yeah.
Really?
Yeah.
You're just gonna take it for that?
Yeah.
No,
Alright.
because we did it when it was supposed to do.
Well, let's check to make sure, because if A prime, B prime, C prime is twice as big as A, B, C, then A prime, B prime should be how much bigger than AB?
3.
The length
A2.
should be twice as big, shouldn't it?
Yeah.
Right? What about B, C, and B prime, C prime? 2 times bigger, right? What about C, A, and C prime, A prime?
Same.
Same thing. So, what I would like you guys to do is we need to calculate the distance using our distance formula of AB, and you're thinking, distance formula, it's been so long. A prime, B prime, BC, B prime, C prime, CA, CA, C prime, A prime. Okay, now this is part B. Calculate the length of each side of the pre-image and image. Okay, so we need to use the distance formula, and I'm going to lighten the work for you guys since I know we've all used the distance formula before. So to lighten the work, all the way over here, Luis's row, you guys will have AB and A prime, B prime. Okay, Jamira's 2 rows, Jamira and Josh's rows. You guys will have BC and B prime, C prime. Okay, Faith and Jessica's rows. Okay, you guys will have CA and C prime, A prime. Calculate the distance. Distance formula right here. Guys, remember distance formula?
Yeah.
Yeah. Y2 minus Y1 squared plus X2 minus X1. So you pick your points.
Well, how come C
What?
C prime and B is in A?
What do we got? BC?
Okay, because the original picture's not here.
But I'm saying like when you if you connect them, then they look closer, don't they?
So why do these look closer?
Wait,
But yeah.
we need to get
Okay.
it right.
It does look a little closer because this is 2 units from the origin, right? That's 4 units. So these 2 are only 2 apart, right? These are on diagonal. This is longer from the origin to start. So when I double that distance, it's longer.
I know, but how do you know which one you put?
You just get to pick.
Oh, and then it's X.
Okay. All right. So use the distance formula. Remember.
I got C.
No, your whole row has CA and C prime, A prime. Practice them both.
Stop touching.
Audrey, Maddie, are they okay?
She wasn't talking about me.
All freshmen who received an orange slip during third hour, please report to the auditorium at this time. Again, all freshmen who received an orange slip must report to the auditorium at this time.
Get to work. Okay. All done already?
For A, for CA. I don't think that's CA. I
If you're struggling setting these equations up, I took the liberty of setting some of them up. So if you want to check your work. All right, we all done? Hear a lot of talking, guys. We all done?
Yeah.
He stopped the recording.
I'll go up there.
All right. So what's this one? AB. Luis's row. AB. What do we get?
D equals 4.
4. A prime, B prime. 8. Is that right? BC. Jamira Rocks row. What do we get?
I got 5.4.
5.4.
Yeah.
Well, B prime, C prime.
10.8.
10.8.
Yeah.
CA. Faith or Jessica's rows. 10. 10.77.
Yeah.
So we can round that to 10.8. Okay.
Oh, no, that's 6.
What do we get for CA? You got 6.3. You got 5.4. Anybody get 5.4? 5.3 what? 5.3. So 5.4. Okay, Faith, you might have definitely run on this one. Okay. So, guys. Okay. So these are the distances, right? These are the lengths of the sides. Remember, A, B, and C. This is the pre-image, right? A prime, B prime, C prime. This is the image, right? We multiplied all these points by 2 to get these ones, right? So if I look at the lengths, what can you tell me?
They're 2 times bigger.
They're 2 times bigger. So is our image twice as big as our pre-image?
Yeah,
that's what I said. You guys see that? Is that kind of interesting? One last thing, and then we'll try another problem. Now you're excited about trying another problem. Now, what if we talk about the area? What if we talk about the area of the figure? What's the area? What's the area of the green triangle up here? The area inside here, right? Right? Long, pay attention. Okay. The area inside there, right? That's the area, isn't it? Now, if I want to find the area of a triangle, it's always base times height. If I look, my height here is this length right there, right? Since it's completely vertical, I can count it. It's actually 1, 2, 3, 4, 5 units long, okay? So this height right here is 5 units, right? How long is this base? 4. So if I want to find the area of the green triangle, we do 1/2 base times height, which is going to be 1/2 of 4 times 5. Okay, 10. Does that make sense? Okay. Now, Long, since you want to talk so much, give me a prediction here. How does the area of the black triangle compare to the area of the green triangle?
Twice.
It's twice it?
Like, bigger.
So if this was 10 for the area, then the area of the blue one should, or the black one should be what? 20. So Long's prediction is the black triangle is the area of 20. Do you guys agree? Okay, well, how long is A prime, B prime? 8. How far is it down to C?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our height right here is 10. Right? So the 1/2 base times height, half of, oh, that's an 8. Half of 8 times 10 is 40. Long, were you right?
No.
Okay. So why is it 40?
Because the area is increased.
Areas what?
Area is increased times 2.
Oh, not just 2. It's increased by 4. Right?
Right.
So
The factor here is 4, Because when I figure out area, how many lengths are we using? 2. Since I increased by a scale factor of 2, all my lengths are increased by 2, right? So I'm using 2 lengths here to make this area. 4 times 5, right? I doubled both those lengths to get 8 and 10. So since I multiplied both by 2, 2 times 2 is 4. This factor right here is 40. Or not 40, the factor is 4. Okay? Does that make sense? Now what if my scale factor was 3? If this was 10, what would this be? It would be 30. It would be 60. It would be 90. Right? Because the 4 and the 5 would increase both by, not by 2 this time, but by 3. Right? So then these are both multiplied by 3. And 3 times 3 is 9. So then my area would be 90 and 10. Okay? The reason being, Justin, is when we do a size transformation, the length of the sides increase by a factor of s, and the area increases by a factor of s. Take a shot. S squared. Good. Okay? So, when we do a size transformation, the side lengths change by a factor of s. The side lengths change by s. Okay? They get multiplied. Alright? And the area changes by s squared. And the reason why the area changes by s squared is when you calculate an area, you multiply 2 lengths, right? So the s factor is in there twice. Right? If I do an area of a triangle, height times width, height times base. If I do a rectangle, length times width. I'm multiplying 2 lengths, so the s part comes in twice. Right? Any questions?
No.
One last question for you. How does this affect perimeter? Remember, perimeter is the sum of the side lengths, right?
It just increases
No, not by 2, but okay, by 2 because we used 2 this time, right?
Yeah.
It increases by s. Since perimeters are the addition of all our side lengths, perimeter also increases by s. Right. Any questions? Anybody?